Welcome back to Program Logic and Design. In this section, we're going to discuss how an array can replace our nested decisions. First of all, I'd like to remind you of what an array is. A good analogy of an array is an array of mailboxes. So a single row here will be an array of mailboxes. And as you can see that each mailbox has a unique number. So a single cell of an array is a single mailbox with its unique address. Now the contents of each cell can be anything. Here this lady has a package. It can be a letter. It can be anything which we can put within our mailbox. Now if I had to ask you to count from 1 to 10, you would start at 1, obviously. Now with arrays, you need to remember that you need to think like a computer. You need to start, when you count arrays, you need to start at 0. So if you had to have an array length of 10, so 10 little blocks, 10 little apartments of a building and such, you need to start at 0. And element at index 8 is going to be whatever the contents within you. I must point out that the highest subscript value will always be 1 less than the size of the array. So in other words, the number of elements, because subscripts are 0 relative. So if I've got a 10 element in an array, then my last element is going to be 10 minus 1, which is 9. Back to arrays that can replace nested decisions. Now, we're going to run through an example, human resources department dependence reports. Oh, quite a mouthful. Now we're going to list employees who have claimed 0 through 5 dependents, and we're going to assume that no employee has more than 5 dependents, of course. And the application produces counts, as you can see, for the dependent categories, which kind of uses a series of decisions. So if it is 0, we're going to count the dependent 0 count. If its dependence is 1, we're going to count dependence 1. If a dependence is 2, we're going to count how many dependents have 2. If it's 3, we're going to count all the ones that have 3 dependents. And if it's 4, we're going to count all dependents that are 4. And lastly, if it is 5, we're going to count all the employees that have 5 dependents, and we're going to use a counter, which is count dependents for 5. So this is an example of a typical dependence report. For this example, our application does not scale up to more dependents. So it's just 5 dependents, that's it. Here is the flowchart in pseudocode of the decision-making process using a series of decisions. This is the hard way. So let's see what's happening. If it is 0, so our dependents are 0, we are going to have a counter just for 0 dependents. We're going to have a counter just for if they have 1 dependent, the employees. We're going to have a counter for if they have only 2 dependents. If they have 3 dependents, a counter for 3. If they have only 4 dependents, a counter for 4. And if we have eliminated all of these questions, 1, 2, 0, 1, 2, 3, 4, then we don't need to ask if they have 5, because we've already asked all their necessary questions. Therefore, we're just going to have an else that counts our 5 dependents for the employees. Now, you would place this nested decision within a loop, of course, till you reach the end of file. So how can we replace that nested decision with an array? An array will reduce the number of statements needed. 6 dependent count accumulators are redefined as a single array. And we're going to have a variable as the subscript to the array. Now, array subscript variables must be, firstly, numeric with no decimal places, initialized to 0, and incremented by 1 each time the logic passes through the loop. So here we are initializing our counts for our departments. We know that there are 6 departments counting from 0 to 5. We have 6 elements in our array. We are initializing all our elements to be 0. And we're going to start with our department equals to 0. We're going to go count. So at position 0, we're going to whatever the previous count was at position 0, we're going to add 1. At whatever position counts at 1, we're going to add 1. At position count 2, we're going to add 1. At position count 3, we're going to add 1. At position count 4, we're going to add 1. And at position count 5, we're going to add 1. If you have a look here, I have drawn the array of cells here for our dependents. So at count sub 0, we have initialize 0. At count sub 1, initialize 0. At count 2, initialize 0. Count 3, initialize 0. Count sub 4, initialize 0. And count sub 5, initialize 0. So what we're actually doing now is that we are using a array here to help count our elements, or our dependent 0 has occurred within our loop. So what's quite nice is that we are working with the arrays here. So at position 0, when dependent is equal to 0, at position 0, we add 1 to our previous counts sub 0, and we store that into the original count sub 0. We do that subsequently for dependent 1, dependent 2, dependent 3, dependent 4. Now, the decision-making process is still cumbersome and it's still hard. You can see that arrays can be used in the program, but do not necessarily actually simplify the processing. So here we try and simplify the processing a little bit more. Where dependent was 0, we now adding dependent here, the dependent variable. Because its dependent is 0 already and we have 0, 0, so we might as well just use the dependent variable, because dependent variable at that particular point is 0, at that particular point is 1, at that particular point is 1. So at count sub 2, we're going to add 1 to count sub 2 variable and add those two. The total of that will be stored into count sub 2. All right, we've improved it a bit, but it is still cumbersome because we are still using a whole lot of nested if statements. So if we have a look here, we have a repetition happening. Count dep equals count dep plus 1. Do you notice that this processing, that processing, that processing, that processing, that processing, and that processing are all the same? So we are going to use this array to simplify the processing. In other words, we can eliminate all these if statements, take this processing here of count sub dep, which is our dependence, is equal to count sub dep plus 1. And what we're going to do is we are going to add that into a count dependence module. And all we're going to do is whatever that dep is, whatever you entered in as at your get ready, or as once you have finished your get ready and you've already entered in your first dependent, when you enter your second dependent, it's just going to store whatever that dependent is, whether it's 0, 1, 2, 3, 4, 5, you are just going to store it straight into that count dependent variable. All right, let's play a computer here. I've got my department variable. I have my count sub 0, count sub 1, count sub 2, count sub 3, count sub 4, and count sub 5. What I'm going to do is the first run of my loop, so when I get into my get ready, I'm going to enter in 1. So when I enter in 1, my 1 goes straight into count sub 1. Then I'm going to enter in 5 on my first loop. So at 5, it's going to read, okay, it's 5, count sub 5, so it goes straight to count sub 5, and I'm adding 1. Okay, so now I've got 1 stored in count sub 5. Then on my third run, I put in 4. See, at count sub 4, straight away it gets 1. All right, let's say I get another 5 dependents. You'll see now my 5 dependents, I've got my 1, which is over here, and that's getting added to my previous one, which was 1. So 1 plus 1 will be 2, and 2 is now being stored into count sub 5. Let's say I get 0. You can see 0 just with my calculations here. I'm using an if statement here. So if this cell here is equal to 1, then it is going to just be 1, else it's just going to be an empty space. And you'll see it subsequently changes per indice. So whatever the index is, or the sub in this case, it changes for this formula. That is why I have a whole lot of noughts here and a whole lot of ones here. But as we change it, so let's say 3, 2, 1, 4, 5, and 2 again, you get your running total here. So my totals are all here. This is all that has been stored within my count sub 0, in my count department variable. And so what we're going to do now is that once we get to our end of our program here, so I'm going to lower this. So once we get to our finish up, what's going to happen in finish up is we're going to print out. So we're first going to start at department 0. So in other words, we're going to start with our first cell. And what is stored in my first cell? We output dep, which is we're working with 0 first, and whatever my count department is. So whatever my count sub 0 is, and in this case it is 1. And then we're going to increment department by 1. So we're going to go towards count sub 1. We're going to loop. We're going to output 1 and his total, which is 2. And then we're going to increment department again and loop, and we go to count sub 2. And what is stored in count sub 2? It's 2. Count sub 3 in our next loop. 1 is stored in there. 4. Loop. 2 is stored in there. Count 5. Once we've outputted 3 for count 5, which is my sum, my total, we're going to increase my department. And we're going to increase 5 plus 1, which is going to give us a total of 6. Is 6 less than 6? No, it's not. It's actually equal to 6. So we're going to be returning right back to our mainline logic here. And we stop and end our program. Here is the pseudocode of the flowchart which we've just spoken about. If you have a look at our module here, account dependence, all we're doing here is with every loop, our count dependence here, this is our detailed loop as such. And count dependence here is within my departments not equal to 999. So it's going to loop and loop and loop and loop until we type in 999. So the user has got control here of how many employees and their dependents we are going to be entering in. So we can count how many total 0 dependents, 1 dependents, 2 dependents, 3 dependents, 4 dependents, and 5 dependents. And that is how we are using a loop, using arrays without having multiple nested if statements. Please join me in the next video in which I'll be discussing using constants with arrays.